So hi, my name is Paige Bailey. I am about four and a half years experienced with Python in various capacities. So I started learning when an earth sciences software package that I use, it's called ArcGIS. It's a mapping utility. I noticed that it had a little Python icon in the corner, and I clicked on it and sort of didn't look back from there. So Python is ubiquitous throughout a lot of different places, and places that you thought that you wouldn't ever use programming at all, you'll probably be using Python. All right, so since this is for absolute beginners, let's start out with the basics. What is programming? What are your thoughts about this? When you think of a program, what do you think of?
Translating English to machine language.
Okay. And some other ideas? Like, yeah?
Basically a program. Writing for a program.
Writing for a program? Yeah. Something that like people do in the Bay Area who work for Google and Microsoft, that sort of thing. That's, I don't know, before I started computer programming, that's what I thought, was just like, oh, it's this thing that people do in laboratories, or if you work for a software company, then obviously they're concerned with programming. Who else would possibly be concerned with programming? But yeah, so just kind of the basics of computers, right? A computer is a machine that stores pieces of information. That is its job. It can do a lot of different things that are cool by association, right? Like your phone. Your phone is a computer that's more powerful than the rocket that sent people into space however long ago, right? But it's still just a machine that stores and transmits things of information. It moves, arranges, and controls bits of data, and it contains a detailed set of instructions for what that computer should be doing with its data. So for this class, we're going to be using a program called Code Sculptor. And is everybody online? Is everybody connected to the internet right now?
Do you know what the network security key is supposed to be?
Excellent. So I was trying to get that.
Yeah, so Temu guessed all one word. Then you'll have to go into a browser and use the information printed on your badge.
Yeah, so there's So on the back of your badges, there is a username and a password, and you can use that to connect to the internet after you get on. So if anybody has any difficulties logging on, just let me know. But once you get logged into the internet, you'll want to go to www.codesculptor with a K .org. So that address right there. And is everybody looking at this web page? Or if you've got Python installed locally on your machine, you could do that too. Okay, so Code Sculptor is something, my first Python class in university used this to teach us how to do it. And also, if you use Coursera courses, this might look pretty familiar. But yes. So it was developed by Scott Rixner at Rice University in conjunction with a couple of other faculty. It's based on a couple of programs, CodeMirror and Sculpt, and I have links for these in the presentation as well. And if you want to learn more about Python after taking this course, you want to get a little bit more in depth, do some tutorials, do some class assignments and those sorts of things, then you might want to check out the course that they have on Coursera right now, which also uses Code Sculptor, called An Introduction to Interactive Programming in Python. And their vision for this is that it's going to be, I believe, a 3-part series to teach fundamental concepts of computer science. So not so much concentrating on the new and fun libraries that are being developed right now and, you know, placed on GitHub, but just the fundamentals of computer sciences and how you're able to make educated decisions about about some of the programming concepts that you might read. So there you go. I also have a link to the course down there. And the first one is running from September 15th to November 16th. So it's in session right now, but feel free to jump in. It's pretty easy to get caught up. And as long as you register before that last date, you'll have access to all of the course materials. And that really is the most fundamental part. Like, just make sure that you register and then do the materials on your own time. So interacting with Code Sculptor. If you look up in that left-hand corner, you're going to see several buttons. So there's like a little arrow pointing right and a thing that looks like a floppy disk and a few other tools. And those correspond to run, save, load a fresh URL, open a local file, or reset the entire circumstance. So how about you click the little right pointing arrow just to see what it does? Yeah, and it should have a little GUI popping up for you. Is anybody using an older browser that doesn't have that functionality? Or is it all working? Cool. Yeah. So the little GUI that popped up is actually a direct result of the code that's written in the left-hand portion of that screen. So just those few lines of code, we're able to create that to make it have this little pop-up for you to play with. And on the right-hand side of Code Sculptor, you're going to have links to documentation specifically for the program and also to Python. Demos, so things that have been created by classmates and people who have taken the course throughout the year. And then also something called visualization mode, which we're not going to really go into today, but feel free to play with afterward. And I think it's currently being developed as well. So let's see what Code Sculptor can do. Yeah. When you click the little right-hand arrow, you should see something like a little pop-up that has click me, and it gives you the message, good job. And again, this is, 27 lines of code, 27 lines of code with commentary, right? So it's a little bit impressive that such a small amount of text can make something that's so immediately visible, right? And let's also take a look at some of the syntax for this. Like even if you aren't necessarily able to pick out, what this formatting is, right? Like def, what is a def? And what does global mean? Like what are these words and why are some of them different colors? You're still able to pick out things like good job or welcome or red, right? Or click me. So if you make very simple modifications to this, right? Like welcome to PyTexas 2014. And my browser went away. And let's see, so mouse click, message, welcome. Are you excited yet? And so change the color from red to, say, green. Then you save, you run, and you see that something's wrong, right? Like you're not able to see the entire message. So you can make sort of inferences about what the program is doing and how the way that it's constructed is displaying things on the screen. Like obviously the message is displayed right here, and you can say things about it by using this canvas.drawText message statement down here under the define draw. So as you make modifications to this code, you can see it immediately expressed in the pop-up over here. And you might have also noticed that whenever you did make these modifications, the URL changed up at the top. So it gave you a .py file. And these .py files that you create after you click save, you're able to copy and to send to anyone in the entire world. So they would be able to run your program, to make modifications to it if necessary, save it themselves, and then send you a new link. So every single update that you make to this, okay, so say I save it again, right? And run it. Howdy. The URL changes. And if you want to go back, you would just have to decrement that last number to what the original statement was. And it'll go back in time and sort of give you what your previous code example was. So it saves every step that you save. And that's one of the other things that I really like about Code Sculptor. So back to the documentation and the demos. Another thing that's very, very hard when you're first starting out is to find ways to make tangible, visible progress other than just, printing a string to your console or finding out what data types are. Right? So to be able to do something that has a big result very, very quickly is incredibly beneficial. And all of these things right here, these are a series of games created by students. These are GUI demos, GUI games using Python, or GUI examples using Pygame, tk-enter, and PyStep. Like all of these things give you insight into what your code is actually doing. So this is a Tetris clone that's created using 528 lines of code. And going through it, you can see a lot of details about the structure of Python syntax, right? So you have a global, you have something called a define a function, and some ifs and some elifs and a for statement. And obviously something is important about this indentation because why else would they be doing it? And it looks like these things off to the side with hash marks, they're kind of commentary. So everything that is creating that Tetris game, you can see expressed here. And you can modify it, you can change it, you can see how it works or see how it breaks and see like if there's any way that you can make it better or personalize it. So, to recap that, use Code Sculptor, explore, make changes, and see how they impact it as a whole. Check the documentation. And if you're still in doubt, Google it. Stack Overflow is a great resource. So are various other places around the internet. Like if you Google an error message, you're going to get an answer almost immediately as to what is probably causing your error message. And most likely it's syntax or something silly. So like missing an apostrophe at the end. And that's just a matter of debugging. But Python. So let's start with what it can actually do. Is everybody still in Code Sculptor? Is that correct? All right. So try typing these statements into Code Sculptor. You're going to have to use the print. If for some traditional Pythons, if you have it downloaded to your machine, you wouldn't have to say print at the beginning. But yes, so just type in print 3 plus 12 and hit enter. So similar to this. Oh. and then hit run. And it should give you something on the right similar to 15. And there are also, there are basically every operation that you could do with the traditional calculator, you're capable of doing with Python. So print 42 minus 21, print 3 times 5, print 9 plus 12 minus 8 times 72, like all of these things. They're capable of being expressed using Python. So mathematics is a big portion, and this is all without importing any sort of module, just basically typing it into the console. So another thing you might notice is that all of these answers that Python is giving you are whole numbers. They're not returning decimal places. They're not returning things called floats. And if you want Python to answer you in floats, you'll have to talk to it in floats. So if you try typing in some of these statements with the double bars, so let's do this. Yes?
This code sculptor use Python 2?
I think it uses Python 2. Yeah. And you can see how that varies, right? Oh, okay. And so these micropauses are going to happen fairly frequently. It's because I'm using my work laptop. And the oil industry is very big on safety. So whenever you're typing too quickly, they decide to sort of deter your typing speed. And you get a little pop-up saying that you should take a micro break or a pause. Yeah, so sorry about that. I've put stoic quotes instead of safety reminders. So but yeah, so as you can see over here on the left, if you print 11 divided by 3, you're going to get 3. And that's because it doesn't really know what to do with that remainder. But if you talk to it with floats, it will give you a more reasonable answer. So back to the slides. You can also use things called comparison operators. So the double equals, you've probably seen that before. It doesn't mean equals in the sense of an assignment. If you see a single equal sign, that would mean an assignment. But it means you're testing one variable to see if the value for that variable is equal to something else. A bang equals, that's little exclamation point equals, means not equal to. So you would be testing to make sure that those things aren't similar. You also have less than, greater than, less than or equal to, greater than or equal to, and all the rest. So as practice, you can see if you print 2 is less than 3 and you run it in Code Sculptor, you're going to get a response of true. And 2 is less than or equal to 2. That should be actually true. And 3 is greater than 2, true as well. 2 does not equal 3, true. False is less than true. So let's try that. Print false less than true. And you're going to get a true. And true and false are something called Booleans. And whenever you're doing tests of things, for example, user input, sometimes you ask for a name, right, on your website, and somebody would return something that is very obviously not a name. So you would want to check to make sure that the input that you're receiving isn't a number, it isn't a numeric value, it's actually a string containing a person's name. And that would be a circumstance where you would want to use true or false. So strings. Examples of strings. It's a beautiful day. Goodbye, cruel world. And if you try typing one without quotes, for example, you're not going to get a return. So if you type in print Aggies without quotation marks, you're probably going to get an error message. So let's see what that would look like. Yeah, so name error, name Aggies is not defined, right? And that's just telling you that if you want a string, let me comment that out. If you want a string, you're going to have to tell it that you want a string. If you want Aggies to be a variable, then you would have to assign it as a variable. So again, Python, computers are not exactly the most smart creatures in the entire world, right? So if you want to talk to your computer and have it communicate something, you're going to have to tell it precisely what you want it to communicate. And strings are examples of things that you can directly print to the console. String operators can be concatenation, so using the plus symbol, or multiplication. You can make your strings repeat themselves infinitely. So Aggies times 5,000, 50,000. I'm not sure I can handle that. But Aggies times 50,000. And it stretches out into infinity. But yeah, and Aggies plus, are you excited? So you're able to do string manipulation quite easily. Another thing that should probably be noted is that you can't mix data types whenever you're doing manipulation like this. So for example, if I had an integer value, if I wanted to say print, I just ate 4 kolaches, you would get an error message because you're trying to tell it you're trying to tell Python that you want a value back that is a mix of text and a mix of numbers, and it has no idea how to process that. So you would have to say this. And what this str command is doing is turning that integer of 4 into a string value. So it should be able to work. Let's see. Let's see how. Control. There we go. No stuff. So there you go. There it works. So strings, you can multiply them, you can add them, and that's concatenating. And that's how to deal with strings. Variables. So saving a value. If it's all well and good to be able to print things to the console directly with human intervention, but if you actually want to save that value, you would want to give it a name. And that's similar to what we did before with the Aggies example. Our Aggies is a variable. We have assigned Welcome to PyTexas 2014 as its value. Its value is a string. And we're able to print that variable to the console. We're able to manipulate it and do anything that we want to do with it. And if we make modifications to the variable, if we add, are you excited? If we multiply it by 2, that still doesn't change the variable itself. So Welcome to PyTexas, Aggies, is going to be the same until we actually redefine it and modify it. So if we did want to redefine it to be Aggies, the current version, plus Are You Excited? And then we printed it off. You could see that it's been redefined. However, it's not redefined up here. So that's an example of how you can do variable manipulation as well. Strings, another thing I should probably mention, you can create a string by either using single quotes, so single quotes, or double quotes, and it'll still return something that looks like a string to you. So creating variables, assigning new variables. You can have colors representing other things. And your variable names don't have to make a lot of sense. Like they can be anything from names that are representative of what the value should be to just something like A2, B3, or just a generic value, or anything actually. Except for numbers. You can't redefine things. And if you have any experience with, I believe it's Lisp or something like R, you're able to redefine anything to be a variable name or a function name. But in Python, no. Like you can't go into your terminal and say, I would like for 4 to be rainbows. Print 4. Yeah, you're going to get an error message. You can't assign a value to a literal statement. And I believe it also works this way for things like def, which is that word that we saw earlier, right? Def is the when you would define a function, which we'll talk about later, you would want to use def, and you can't assign it to have any sort of name that you would want. So variables, you can calculate it once, but you can keep the result to use it later, and you can keep the same name for a variable and change a value. And some other things that you can do with variables is index them. So like from a string, let's see, a So from a string, it starts off from left to right and indexes every character within that string. Python also starts counting from 0. So instead of counting from 1, you would be going 0, 1, 2, 3, 4, until you get to the end of this string that you have listed here. So if you want to type, if you would want to obtain, say, this M character in Dumbledore, what do you think you would type? You would go 0, 1, and 2, select it from your string name, and there you would go. You can also do slices of your string. So if you wanted to get all values from this third character to the fifth character, you could do that. And it clips it off. It clips it off before you get to that. So that is called slicing a string and obtaining a small portion. And you might also notice I'm using square braces to access this. So this A would be the variable name. You open up your square brace, and to get the position of any of these values, you would just give a numeric value to give its placement. So data types. We've done a little bit with manipulation of things that you can directly run in the console, but the different types of data. So strings we've discussed. There are things like whoop and text, and you can print them directly. Integers are numeric values. Floats are things with points, like 0.0, things that are not integer values. So whenever you're curious as to what a specific data type might be, you can use type, right? So what would this be? It's a string because it's giving us a portion of the string. We would be returning string values if we, meaning of life. If we wanted to find out what the data type for this would be, we would just take a closer look through inspection and see that it is an integer value. You got this 42. If you change it, you put a decimal and a 0 at the end, it would be a float, because Python is intelligent enough to realize that if you are giving it a .0 value, then it probably should be giving it a little bit more attention. So there are also other things called lists, right? So a list is just a sequence of objects, John, Paul, George, Ringo. Or a series of grades just collected into one neat little bundle. And you can index through a list precisely how you index through a string. So Beatles, John, Paul, George, Ringo. When you print it off, it will give you the square brackets in addition to a series of strings, 4 strings, with the names of the things that you had designated to belong to the list that's called Beatles. If you do a type on Beatles, it'll tell you that it's a list. And you can determine that you can index through it the same way that you would index through a string, except instead of the way that you would index, so when you index through a string, right, when you open up the square brackets, and you have a numeric value, it cycles through each character in that particular string. If you cycle through the components of a list, it returns the first value. So you'll get John instead of what you would be getting if you were cycling through a John string, right? So both of these are examples of lists. Lists can contain numeric values, they can contain strings, they can contain tuples, they can contain other lists. Like they're pretty multi-purpose, and they're ubiquitous throughout programming. And again, the lists for Python, if you're going to index them, they always start at 0. So if you had gotten this, and you wanted to, somebody asked you what your favorite Beatle was, and you like George a whole bunch, you would want to tell them that print my favorite Beatle is, and then Beatles too. And you're also, if you remember before, whenever we tried to concatenate, which is when you add plus signs, when we had tried that before, it wouldn't work with an integer value because the data types were mixed. But as long as your type, and you can double check and verify this, as long as your type for this value and the type of this string value are the same, then you're capable of adding them together. If you wanted to add a list to this, right? Like if you wanted to say, my favorite Beatle is just Beatles the list, it shouldn't let you do that because the types can't be mixed. So another data type is Booleans, and we saw that expressed before with the true and false values. They're pretty simple to figure out, but can get complex. So usually they're used with regard to comparisons like this, right? So if I wanted to check if the type of my list equals the type of the value that we had gotten before, so George the string. If I wanted to check if those two types were similar, I could do it this way, and we would get a false because those two types are not equal. If I wanted to check to see if the type of the first value in my list equals the third value in my list, we'd get a true because they're both strings. So those are primarily what true and false would be used for Booleans. They would be used to check if you want a string and you want to make sure it's a string, you would check a type and you would get an affirmative if it is, or it should potentially be changed to something else if it's not. The same with integers. If you want to make sure that all of the values that you're receiving are integers instead of not a numbers or just an empty array, then you would want to check true or false just to make sure. So it also works in conjunction. So if you want to say if 1 equals 1 and 2 equals 2, then you would get a true value. If only one of the comparisons is true. So if 1 equals 1 and 2 does not equal 3, then it'll return a false. You can do the same with or, and the same with not. So not returns just the opposite of what Python would initially give you. And again, this entire slide deck will be up and ready online immediately following this. It'll be on my GitHub, hopefully with a modification to fix that one error. But yeah, so it'll be a reference for you later on whenever you'd like to use it. Logic statements. So let's get into the nitty-gritty. If. So if a condition is met in programming, you would perform an action. Like all of the things that I've mentioned before, data types, they're important, but they're also not exactly the most exciting things in the world, right? Like it's a little bit hard to determine how all of these things placed together can make something as expressive as a program, something that you can see visible results. So in real life, if and else statements just happen naturally in the English language. Like if you're hungry, let's go eat lunch. Or if you like Frisbee, let's go play. So in programming it, especially in Python, it works the same way. If a condition is met, then you can have a result either displayed to your console or used elsewhere in your program. So you can also add a choice, right? So if you're hungry, let's eat lunch, or we can wait a little while and eat in an hour. Or if you like Frisbee, let's play. Or we can play rugby. And those statements are also capable of being expressed in Python by using an else or an elif. So if you have multiple options throughout your code, then you can designate them with these sorts of things. So just looking at what we have here, we have if name, which is a variable, equals page, which is a string, we can have it print out this. Or if name equals Walker, which is also a string, we can have it print out that. Or else, if we get a value for name that isn't page, if it's not equal to that, or if it's not equal to Walker, then we can have it print out imposter. So seeing this expressed in a real world situation, right? If we go on Code Sculptor and we look at some of these demos, right? Like there's a DDR clone, and I'm not sure that we have, I don't think that we have audio up here, but this program runs a Dance Dance Revolution clone in your browser. And you can choose a song, and as the things scroll up, right? And I'm also not very good at Dance Dance Revolution, which you can probably see. But yeah, so this is obviously a very complex game, right? It's something that is having a lot of bits and pieces getting together to work. And you would wonder, like, oh, they must be doing something incredibly complex, right? Like there must be a bunch of additional features that haven't been discussed yet. But in all honesty, so if you look here, right, like this is setting global variables. This is a comment, which is expressed with a hashtag. But time is just an integer value. Splash is just determining, it's just a Boolean. Score is just initially at least, it's just an integer value. So a lot of the concepts that you see expressed in this game are things that we've already covered. Song list, that's just a list with two choices. Dance list, a list with two choices. Dance choice, a value. So another thing, loops. And there is support for GIFs. I am very excited. Okay, so loops are chunks of code that repeat a task over and over again. Counting loops repeat a certain number of times, and conditional loops keep going until a certain thing happens or as long as some condition is true. So this GIF that you're seeing right here is from Dude, Where's My Car? And I also did not really anticipate that my PowerPoint would support it. So what they're doing is they're asking each other what's on their back, and they're using the qualifier. So it's an infinite loop. Actually, it would never stop. But yes, so counting loops repeat a certain number of times. They just keep going until they get to the end of a count. So if you have a list, right, and lists are indexable, we've discussed this, you can go 0, 1, 2, 3, 4 until you get to the end of it. And there are 5 values in this list of 1, 2, 3, 4, 5. So for some variable in this list, which has 5 values, print this string followed by that variable's name. So, and I'm not sure if you can see my cursor. I hope you can. No, you can't. Okay.
It was there.
Yeah, it was-
Okay, cool. Yeah, I was wondering, I've been messing with it over here, and I was hoping that you would be able to see it. But yeah, so for some variable, doesn't matter what it's called, in this list, print this string followed by what that variable's name is. So it runs through, and for as long as it has values in this list, it prints the string and the value's name. So we can play with this in Code Sculptor, right? Like, for value, and let's bring back that Beatles list. So John, Paul, George, Ringo. So for each value in this list, we're going to say my favorite Beatle is and then value, right? So what will this do? This will cycle through each segment of this list, right? Each component that it has, and return my favorite Beatle is that Beatle's name. And then at the end of it, you'd have to print it. You should have something similar to this. So we mentioned before that lists can contain any kind of objects, right? So you can have integer values. You can have other lists. So Ian, Kevin, Curtis. So what would that do for our indexing? Well, let's see. And that's always the best thing that you could possibly do in programming or in Python. Just try out different things and see how they affect it. So instead of giving us a type error for our function, right, it just printed off every single value that we had in this list. It wasn't looking for strings in particular. It wasn't looking for integers in particular. It wasn't even looking to see if our data type was, like a singular value and not something that had additional components. It just printed off whatever it had listed in that list. So that is an example of looping. And the for keyword is used to create this kind of loop. So it's usually just called a for loop. And again, these are everywhere in programming. So conditional loops repeat until something happens, or for as long as some condition is true. So if we start with an additional count, or a count of 0, which is something that you saw in the Dance Dance Revolution, example. If you start with an initial condition of 0, and you say while this count value, this count equals 0 value is less than 4, you print the count is, and then whatever the count's value. And you're saying, okay, so in this while loop, what I want to be doing to count is increasing it by the value of 1. So every time, as long as count is less than 4, this loop is going to go over count, and it's going to print off the count is, give its current status, and then it's going to add 1. So this is an example of the output from the screen. You would have the count is 0, that's the initial state. It goes through the while loop. It adds 1. So you end up with the next time it comes into the while loop, you would have a count of 1, goes through again, gets a count of 2, goes through again, and gets a count of 3. So we could say, we could give a condition for our program that we just created, right? The for loop program, that we only want for value in Beatles while value has a type that is, well, value equals string, right? So value equals string. You could print that and the value. So this time when we cycle, or type of value, sorry, the perils of live coding. So this time, Walker, do you know why this would be giving a problem?
Well, you have to call it.
Well, yeah, I added the colon. It should work.
Well, now it's, well, you also created an infinite loop.
Oh,
You put an if rather than a while.
okay. If type, sorry, yeah, if type of value is a string, then, so for each value in Beatles that has the type of a string, it should print that value. So in this loop, we don't care about the integers. We don't care about the list, even though the list contains strings. We just care about the string values that we have first expressed. And I guess that's another good point. So while usually it runs until it stops, and it would be hitting those string values every time. So algorithms, that's a scary word. When you think about an algorithm, what do you think of? Like, it's really, like, they use the term a lot in mathematics. It usually means a detailed way of doing a problem that's very complex, complicated, lots of steps, might not be the most immediately obvious thing in the world, but it's really just a set of instructions that are bundled together in a neat, concise little package and sort of delivered to the computer saying, all right, so there are a lot of things that I want you to do, but I'm going to bundle it up, put a stamp on it that says function, and I want you to do everything that's in this function. So just don't make me type it, just do whatever I say that I had expressed before, do everything in this spot. So how would you make a pot of coffee? Like, this is a set of instructions. right? Like you would get a flavor of ground coffee if you're me, because you're too lazy to grind it yourself. You'd get a coffee maker or a French press. You'd get filter paper if you have a coffee maker. You would get the pot of water. You would make sure that it's plugged in. You would make sure that you paid your electricity bill. You would do all of those things, and so on and so on. And you know, hopefully, you know, your water is running as well, so you would have had to pay the water bill. But to us, it's just make a pot of coffee. Like if you ask your friend, like, oh, hey man, like, you know, make sure that coffee's around whenever you leave, because, you know, that's something that I would like to have later. Then you're not going to tell them all of these steps. You're just going to state it in a single sentence. So functions are a way for us to communicate those sets of instructions that are obvious to us to the computer to make just one call, right? Like, so we don't have to tell it every time, I want you to loop through this list, and if this list works, I want you to loop through this other list over and over again. You just bundle it up into a nice little package and tell the computer to do those steps. So this would be an example of a make coffee function, right? So what it's like in our minds, make a pot of coffee. That's our bundle. That's our thing that we want to communicate. And in Python, you could say it like this. You could say, I want to make coffee. Make coffee. That's the end goal of this. And in order to make coffee, I'm going to need coffee grounds. I'm going to need a coffee pot. I'm going to need water. I'm going to need filter paper. So those function parameters are the things that you would need in order to make the function happen. So this is a very, very simple function, right? We're going to define it, and we're going to call it. So in Code Sculptor would be def beverage, right? And then print, have you had a cup of coffee today? And then just so that the computer knows what we want it to do, we're going to call that function immediately afterward. So there you go. That is, wow. Secretly the ceiling opens. It's like a football stadium. Yeah. But yeah, so we defined a function. Our function is called beverage, and all this function does is print, have you had a cup of coffee today? So that would be my beverage of choice. I don't know about the rest of you. And then at the end of it, we would call the beverage function. So it's printed off to our console precisely what we asked it to. Have you had a cup of coffee today? We also didn't require any input from the user for this beverage statement, right? Like it's just saying, like, you don't have any options. You're gonna get your coffee. That's all that's gonna happen. Like we're gonna ask you this, and that's the only thing. So when you print off the value of this function, that's what you get in choice. But what if people aren't as excited about coffee as all of us in this room are, or at least me? You can define parameters, right? So you can say if this beverage, our function beverage, asks for a drink from our user, and it prints off, have you had a cup of whatever your drink is today? So let's try this out. So add the concept of drink. Drink would be a variable. Have you had a cup of? drink today. And we can say, what do people like? I don't know. Orange juice. I saw that out there. Right. So our user is going to say, I would like orange juice to be my drink of choice, to be my drink for this beverage. When you print it off this time, you see, have you had a cup of orange juice today, displayed in your console. So this would also be an example of a time when you would want to use types, right? Like, because someone might not have understood the question, someone might not have understood that they wanted a string, right? Instead of just like some random value. So you could say, whatever your value is for drink, you can turn it into a string with that command. So let's see. 4. Why not? Have you had a cup of 4 today? And it's taking that because it's an integer value that goes into this. You can also say if type drink equals string, print this. Else please tell me a drink. Please return a string. So in this case, your program would be returning, your program would recognize that the person's input was an integer instead of what it needed to be, which is a string. And since the user wasn't giving you a string value, then it's asking for a correction to be made for that input. So to recap, functions are defined using this DEF. Oh, that's not right. Functions are defined using this DEF statement. They're called using parentheses. They take parameters and return outputs. And the concept of print, right? It displays information, but it doesn't give a particular value. So a return within a function would give a value to the caller. And that's, so for example, in functions, right, like anything that you could put into the console, absolutely any concept you could use a function for. So you could put in while loops, for loops, you could put in other functions, like anything that you could possibly do in a console, you could define in a particular function. So say this, right? Like notice how I have, whenever I called this initially, I didn't have to declare a print statement before this beverage. I just said if the type equals the string, print this or print that. But most functions are wanting for you to return some value. So this time, you would have to ask for it to print since you had return statements embedded in the function. And with that, so I wanted this to be more interactive, than me just standing up and explaining things kind of willy-nilly. So if you guys have anything that you would like to do with Python, like any project ideas or any questions about the particularities of the language and how it relates to other things, how it's different, what kind of capabilities it has that other things can't offer you. I would love to just open up a dialogue for that. And also, again, so there are a variety of options, right? For which version of Python to use. So there's Canopy, there's Anaconda, there's Spider, there's 2.7, 3.3. Walker probably knows of about 5 others. Do you have any other ideas, Walker?
Well, we forgot, the bare bones C Python, you get from the python.org website.
Yeah, there are tons of, there's so many options actually. And and the question,
For the .NET folks, Python for the Java people.
yeah. And then Eclipse, I think Eclipse also lets you do Python development within it.
PyDev is an extension on top of Eclipse that gives you a Python IDE.
Yeah, so there are infinite possibilities for places that you can use Python. You can also open up a terminal in ArcGIS. So I think it's installed locally. And if it is installed locally, we can take a look at ArcGIS. No, license server. Okay. So I'm not able to log into my VPN at the moment, but yes.
Could you, I'm just wondering if it's possible to loop through a list to look for, or something larger, I don't know how big a list could be, it's supposed big, but you could loop through and look for certain values. And so instead of having like Beatles 0, Beatles 1, you could have a variable in there.
Right, right. So a real life example of this would be like if you if you had a list, right, and say your list contained a bunch of well header files or something like that, and they all had a consistent first three letters, and then afterward, some other thing. So you could loop through this list, and you could say, I want you to give me back another list with all of the wells that I'm interested in that start with the letters AB2, right? So you would be able to very, very quickly take a large deal of information and put it down to something smaller. Or as you said, like looking for a specific value, right? So if you had a list of names and you wanted to find all of them that started with a C, then you could loop through that and find it. Or a list of values that you got from a survey. Like if we have any sociologists in the room, sometimes you get fields in survey data that have no response. So you end up with not a number or a 0 sometimes. Or if you're dealing with numeric data, sometimes it's something completely ridiculous, like negative 99,999 or something. So you could loop through and cull out all the information that you don't need, or you do need, that you are looking for.
Yeah, it's very common to have an if statement nested inside a for loop.
Mm-hmm.
So I've got a for loop, I'm looping over something, some list or other thing to loop over. And then there's an if statement to say, if the thing is interesting, do something with it, or if it's bad data, reject it.
Yeah. And a lot of the web scraping that's currently being done by politicians, right? another real world example, it would cycle through a particular region's Twitter feed, right? So like when you think about how you would organize that in terms of a program, it's another make a pot of coffee situation. So you would say something to the effect of, make it big so that people can see. So if Twitter user location equals, and take it off a word wrap. If Twitter user location equals Houston, right? So you would be looking for people in Houston, and this is all pseudocode, right? This isn't an actual command that you could input into Python, but it is, these variables do have corresponding variables that you could use. But so if Twitter user location equals Houston, if Twitter, or if tweet, user tweet, contains Anise Parker, right? Then add tweet to list and add user to tweet list, add user to user list. So this kind of, so this would be an example of something that a group of politicians would use. Like they would cycle through social media. They would try to see how many people are talking about their particular candidate. They would want to see what those people are saying about the candidate, whether or not they're favorable or whether they are voting for this particular person, or like if they have an idea about what they should potentially be doing for their campaign. And they would be able to get a list of all of those Twitter users and everything that they said.
I mean, this is almost not pseudocode. If you just define, if you had a for loop that was going over tweets, defining the variables, Twitter user location and user tweet, and then you also had, outside of the for loop, at the very top, had defined tweet list and user lists as empty lists, then the only things that you would need to do to modify this code is you put a dot between user tweet and contains, and wrap Anise Parker in parentheses, and then you'd go tweet list dot append tweet instead of add tweet to tweet list. User list dot append user.
Yeah.
And that would be production code.
And there are a lot of methods that you can do to lists. I'm talking about this a bit later in the 101++ talk. But yeah, so list methods. And this is another resource that you should use if you're going into, so all of these things. List data has methods like append or extend, insert, remove, pop, index, count, sort. Like there are so many things that you can do with these list values. And the Python website has extensive documentation around all of them. So another example would be, let's see. So if you wanted to cycle through a list of users or a list of, so say you're an accountant, right? Like, and you're getting thousands upon thousands upon thousands of returns from employees who are making purchases for your business. You work for Megacorp.inc, and you're getting all of these Excel spreadsheet values. You could cycle through the values in a particular field of Excel, see if a daily expense is above a certain threshold. So like if you see an employee has made 5 purchases in the last month over $500 each purchase, then you might want to take an additional look at it, right? So again, just thinking about that programmatically. So if employee has purchased 5 things, has purchased 5 business expense items over $500 in the past 3 months. Then add the employee name to a list, right? So that could be an example of a task that you would want to complete. And programmatically, it would look something like if employee that would probably be a dictionary, don't you think, Walter?
Well, so you've got I mean, there's a whole bunch of different functions you can call out.
Mhm.
First, you've gone someplace to list out all your employees.
Yep,
then
and
for each employee now,
it has data.
You go to a dictionary perhaps.
Yeah.
And fetch all of the purchases.
Mhm.
You then filter the purchases to only the ones from the last 3 months.
Right.
You then sort the purchases by their value.
Mhm.
And you take the, say, top 5.
Mhm.
And if the top 5 were, if the bottom of the top 5 exceeded $500, then you go, aha!
Yep. So again, there are a lot of different things that you can do provided you have the data to do it. Python can do data manipulation just like more powerfully than Excel and more powerfully than most languages, I would say. So what are your goals in terms of Python? Like what are you hoping to use it for?
You want to do government data. Government data?
It's government data, so government contracting data. There's there's a few companies that basically have a monopoly and they're buying everyone that try to compete with them. And it's really expensive and it's crap.
Yeah.
So what I do is I go in and I just go straight to the raw source and then kind of do what you were saying, like a lot of single use automation to kind of gather the insights that I need to benefit my clients. And then also scrape it on a regular, like I take all of, do you know FBO.gov? So
Mhm.
FBO.gov is where every single government contract above 25,000 has to go through by law. But when you're talking about like a distributor or a construction firm, they have like key pieces of data which are going to be that are going to be key to deciding bid no bid. And so I take that out and I put another interface on it that matches their workflow. You know, so and that's what we're trying to do.
So
So this is a different thing than like what the Sunlight Foundation does.
I'm helping them actually because of some of the insights that I've
Because
had
they've got
today.
some tools that are about scraping too.
Echelon, yeah, I've been talking to Zach, who created that, because, you know, Echelon, what they're using for scraping, like finding dark money in politics, is exactly the same technique that I've been trying to use to find, like, you know, some dark situations in contracting.
So it's a combination of web scraping and then data wrangling.
Yes.
Because then after you scrape it, the data is still going to have messiness to it.
Totally.
mhm.
And it's, you know, and it's not, some of it's just wrong.
Right.
And you can find patterns to find the wrongness.
Right. And so usually what I've found whenever I've used things like Beautiful Soup and whatnot is when you get the HTML spit out or you get, so inspect element. Like if you look at a given web page, right, like this is sort of a description of what's happening on it. This is the HTML So, and the way that I accessed this, you can access it from any browser. You just right-click, or some browsers. You just right-click, and if you're using Google, you can say Inspect Element. I think if you're using Firefox, there's, what's the? Firebug? Okay. Yeah, but that's an add-on extension that you have to download though. So there's a way to right-click it and to use something else. But yeah, so in terms of Chrome, you would right-click Inspect Element, and then you can kind of cycle through and see all of these different things that are making up components of a web page. And there are a lot of tools that people have developed to sort of spit out the all of this text that's associated with a web page, right? And to cycle through, to query through the text spit out, or that sometimes contains lists, sometimes contains dictionaries, and pull given things. Like, so if I was looking at this web page, and bless you, and I decided that I wanted to find every, this isn't exactly the best example for it, but if I wanted to find every code sample on this list, so Inspect Element, it would correspond to something like this, and you could make the inference that this open caret pre thing would correspond to all of the boxes that you have. So this is an example of a code sample box, and you would find similar pre and then / pre embedded elsewhere. So if you inspect this element, right? You can find that it's also embedded in a pre.
But no,
So-
it's a pre that's embedded inside if you look just at the top, highlight Python.
Highlight Python.
Yeah, just look at the div. Go up,
Uh-huh.
up, up,
Yeah,
up,
there we
right
go.
there.
Yeah.
So that, and then the grandchild is pre, you know you found it.
Mm-hmm. So that would be a way that you could query through this web page and pull out all of the Python samples that are in it. And again, you can do this for any web page. There's a great where it is. Yeah, so there's a very easy to use library in Python called or module rather, called Wikipedia. And whenever you use it, you're capable of pulling in lots and lots of data. It doesn't work so well with tables, but it does allow you to take images pretty easily, and then also it geocodes the location if it has it on that page. So like I was doing a project recently where I was looking at all Texas state parks, right? So all of the Texas state parks had a consistent URL at the top in terms of Wikipedia. So Wikipedia state parks, Texas. There's a list of Texas state parks here, and you would go through and sort of query the park name, which you found from this page, and then ask for the geocoded location right here that's expressed in coordinates. And you can do that for anything. So, and again, like if you're looking for inspiration for Python projects, the Code Sculptor site has a lot of demos with descriptions of how to do it, right? So Star Wars. That has apparently crashed. That's
Delta is 0.
Have
Wow.
you used Python to interact with the Google Maps API?
The Google Maps API, the new one, I think you need a code, right? Like you need a dev code? There's God, what was it called?
Because ArcGIS.
Yeah. Oh my God, geocoding things, and they only let you use like 200 or something if you're doing the online one. Yeah, I got yelled at by the Esri folks for this. But there was something, it's like PyGeocoder. That sounds familiar. PyGeocoder. Yeah. And
Like, I mean, is there an open source?
alternative for geocoding?
Yeah.
No. Not that I,
There's ones you can find that are one-off.
yeah.
Singles, but you can't.
Yeah, and also if you want to do route optimization, like there are ways to do it for smaller numbers. Like Google's very good at it for smaller numbers, but if you're getting into things like, you know, you have 500 points and you want to find an optimized route through all of those.
Yeah, I tried that. There's not a lot of options.
Yeah. So this is what I've used in the past whenever I don't really have another option. But it's if you give it lat long, it can give you an address. If you give it an address, it'll give you lat long. And it's called PyGeocoder. The one that it's based on does not currently work, but this one should work with the version of Google. And ArcGIS, the majority of Python work that I do with it is basically, so we have these things called shapefiles and also culture data. And I have an open source alternative to ArcGIS on another laptop in my bag if you would like to play with that afterward. It's called Quantum GIS. And it also has Python extensions. So that's an option if you're not wanting to pay money for ArcGIS. And if you want an online alternative, there's Mapbox, which is a way to display gorgeous maps online. Mapbox, yes. But yeah, so in ArcGIS, you have these things called shapefiles. And this is the website for Mapbox, and you can try it for free. Very easy to use. There's also OpenStreetMap, but it doesn't really have a way to export maps to additional users. And the licensing for this software, it's not to the point where ArcGIS is. Not in terms of dealing with complex projections and those sorts of things. So if part of the reason why maps are so important to location is so important to the oil industry is because you want to make sure that when you're drilling, 5 miles down, you're drilling in the right place, and it's usually like 30 feet one direction. So that's part of the reason why they're very invested in sort of the accuracy that Esri can offer. But if what you want to do is you want to make something usable and accurate on the surface for people to get directions or something like that, then an alternative like Mapbox would be excellent. Use the right tool for the task. ArcGIS is not always the right tool for the task. And I've just ensured that they'll never hire me, so that works. But yeah, does anybody else have any Python projects that you're currently working on, or something that you've heard about other people using Python for that you have? Yes?
I'm trying to get census data.
U.S. Census, yeah.
And I finally found some code, but I'm not sure how to, I would be good at, it's an example, but I'm not sure how to expand on it. But anyway, apparently it's like a series of if statements, if statements to get drilled down. But what I'd like to do is I'd like to have something set up for some people to be able to pull down data based on table numbers.
Okay.
And all they have to have is the index. Once they type in the right table number,
Mhm.
there's like a
Right. And it's the same way with most sociological data too. And I'm guessing that political science would be very similar, is you get these massive spreadsheets with all the information about a person that you could ever hope to know about them. Well, except for sometimes what you're actually searching for. But having to cull through that data to pull the values that you actually need is a tall task. So when you say census data, are you talking about
There's a census API.
this? A census API, okay.
And
US Census API. Let's see if we can find it.
I'm not adept enough to know how to interpret it.
Okay. So,
It's that if you go to, there's actually some examples that people have written,
okay.
but they don't.
One of the most powerful techniques is just to remember Google, Python, space, the thing you're interested in.
Yep. When in doubt, ask Google.
Because usually, if it's not like totally oddball, somebody else in the Python community has already encountered that same frustration point, and there's a decent chance that they, well, having solved the problem, they packaged their code up as a library and published it.
Mm-hmm. And
Well, there's supposed to be some sort of Python wrapper
For the API.
mhm. And this is an example of the Python package index, or it's a website that has all of the packages that are currently available. It's updated very, very, very frequently. So this is today, Friday, and you can see how many have been added just today, right? Like all of these have listing dates of today.
I
So,
mean, there is one for the census API, but it was a pretty basic description.
mhm.
I couldn't.
Yeah.
Well, and so that's the next thing. Depending on how common your task is, there may be a library or sample code that exists, but there may not be much documentation, because not many people have done that particular thing.
Right.
There's been the energy to drive documentation. So
Yeah.
then you've got two approaches at that point. You can either just write a short little script, or like go into the Python prompt interactively, either way, and just play with it and try to feel your way through to a solution, making changes like one line at a time or a piece of a line at a time, just slowly drilling down to what you're after.
Mhm.
Or
And another really
or maybe
huge
hack open the code.
Another huge thing is to try to find other members of the community who are interested in the same thing that you are. Because having somebody to ask questions, right, like that happens to everyone. Getting another pair of eyes to look over your code to make sure that everything is correct, that's invaluable. Or to say, hey, like I have not seen package type X, like have you seen it anywhere? Have you heard about it? Do you know of something similar that I could possibly use? What's the newest, coolest thing on Hacker News? That sort of thing.
So usually these things, the libraries, click anyone
Mhm.
at random.
We'll sort TV episodes. That sounds fun.
Okay. And let's go all the way to the bottom. Okay.
Are you looking-
There's the page, there's the guy.
Uh-huh.
You could hit the page, there it is on GitHub, so that's
Yeah,
great.
and he probably has a link to his Twitter too, so you can just be like,
Pretty
hey,
cool.
yeah, just be like, hey, dude, what's up? Like, tell me about this thing.
Does everybody know about Stack Overflow?
Yes.
Okay, so if you've got a problem with like library X and somehow like talking to the author wasn't helping, or
Mhm.
you didn't want to do that, the Stack Overflow option, tag your question using Python,
Mhm.
census data, using this library, and here's my code, this is my problem.
Yeah, Python census data.
I'm not at the here's my code point yet, so.
Uh-huh. So formatting census queries using Python wrapper for US Census API. So let's see this.
Are you at all familiar with
No,
iOS programming?
no. That's like Swift. Is that the new thing?
Yeah, for iOS 8, they released, before iOS 6, they released a Sprite framework,
Mm-hmm.
and it integrates with Swift in a very masochistic way. At least that's my opinion.
Yeah.
Um, Going back to the meme that you had earlier that you did in Python, is it hard to have an extra string that runs in the background? Collect metadata as just an example of playing with
You
that type of
an
thing?
extra processor, correct?
Extra process that,
Okay. So,
Yeah.
but, or would it show up by like pulling up your terminal or what have you?
okay, so Python does not do multi-threading the way that most people are used to.
Yeah.
It's useful for like situations where you've got several I/O channels and one is blocking, and so well, let's wait for this channel one is waiting for data. You could be pumping data from channel 2. But as far as like a true background process that's like chunka,
Yeah.
while something else is computing analytics, not so good. Now, it's kind of like a rule in biology that deficiencies usually then turn around and produce strings. So Python is really good at multi-process interoperation.
Okay.
So what you might be tempted to do in 2 threads, which tends to produce more bug-prone code anyway, instead you do in 2 separate processes that cooperate. So you have a data harvesting process that's going chunka in the background. You could have several of those workers if you've got multiple data sources. And then there'd be a data analytics process that's communicating to those guys, those workers, and say mapping and reducing the data as it's coming in.
Yeah.
Because I was wondering, when you showed the very simple meme, it made me wonder if you could have something running, basically saying, shiny, let me get your IP and MAC address up while you're looking at the shiny.
Well, for GUI, that's fine. If you're writing like a desktop application,
Yeah. Not something embedded in the browser.
embedded in the browser again, but you have to then ask, what is the thing in the background and where is it?
Yeah.
The background does not have to be another thread. It could be a separate process on even a different machine. Is the browser making queries to all these external APIs, or was the server doing it? It depends on your application.
And it's also the right tool for the task, right? Like if you want to have an application for the browser, then you're probably going to be wanting to look more at something like JavaScript.
Okay.
I mean, we have Django, but if you want interactivity and beautiful visualization, like nice, pretty, shiny things, it's JavaScript.
I'm just one input. I'm just curious for a side project.
Yeah. So Stack Overflow, as Walker mentioned, it has extensive questions, answers, upvotes, how to convert longitude and latitude to street address. So that's basically geocoding, the question that you were asking. And the top answer is Google Maps API. And then limits on the terms of use are constantly going to be a problem. And another nice thing about Stack Overflow is that they give code examples, right? So you can sort of piece through and pick out bits and pieces, right? So if you see an example Python script, where's one with a lot of activity? Yeah, you can sort of piece out at least what they're trying to do. Also, that's funny. I mean, so this is another thing that you might see in some Python code. If you're running in a Linux environment and outside of the console, it's called a shebang line. You're basically telling your computer what you want to use in order to run the script. So if you were going to be using Ruby, you would have Ruby there instead of Python, or like a bash script.
Yeah, to make a Python script,
Mhm.
like it's a command, like it was already on your operating system, you just
Mhm.
start typing Python space my script,
Mhm.
just type my new command.
Yeah.
You gotta do two things. You gotta, in Unix, add that magic line at the top.
Shebang.
And then you gotta set the permissions on the file to make it executable. At that point, as
Yeah.
long as you put that file in the right place so the system knows to look for it as a command, it's a command.
Yeah.
It's like any other command that's already on the system.
Mhm.
The Windows equivalent is you'd have to write a .bat file. There's no getting around that.
Yeah.
That would then call your script.
Yeah, and I have more familiarity with, let me turn it on. I have more familiarity with writing things in a Linux environment. Like Windows is not my weapon of choice. But
Bistro.
what?
The Bistro.
I have recently transitioned to Ubuntu 14.04, and it is actually much better than all of the 13s that I've tried to play with. 12.04 was my buddy, and he's just not good enough. I haven't had any issues with this thus far. And so there's also a big question if you start talking to people about Python, like which version should I use? Should I use 2.7? Should I use 3? Should I, do all these things? Or if you're in an oil and gas company, they might want you to use 2.4. But yeah, so there might be a question of which version of Python to download. And people have different ideas. It's usually recommended that if you're first starting out, you want to start out on 3. But the integrations that are available in ArcGIS, QuantumGIS, all of those things, those are all running on 2, so 2.7.
I will say that ArcGIS Pro just came out. I have a beta copy of it, and that's Python 3 now.
Oh, really?
Yeah,
Excellent.
It's all 64-bit.
That is very, very cool. Are you affiliated with the ArcGIS community around here, or?
Well, in San Antonio, I mean,
Uh-huh.
I don't know. I mean, I went to the conference this past summer.
The PUG conference or the Realsies one, the one in San Diego?
San Diego, yeah.
I am jealous, man. That looked like so much fun. But yeah, so ArcGIS, if people want to come play with it, or QuantumGIS, let me get.
So is there going to be any discussion, I'm sorry, I thought I'm hogging it, but is there going to be any discussion about loading some of these? Like when I tried to do that, I found that somebody had done something in GitHub that couldn't have to do with the Census API.
Right.
And when I loaded that, I thought I was following the instructions, but instead I needed some other things, and I had to go find them, and load those before they could load, it was
Right.
calling other
Packages.
libraries, I guess it was, or something.
Yeah.
It's very common for somebody to create. So in Python space, there's like what's built into the language itself. And that's this core set that is like lists, strings, and numbers. And then there's the Python standard library. So pretty much, well, anytime that you install Python, in addition to that like core built into the language, you get a standard library.
Yeah, and
It's
all of
really rich.
and
Say batteries included.
so it's on the screen. Yeah.
So there's stuff there that knows how to send emails. There's stuff there that knows how to pull data down from a URL.
SQLite. It's got SQLite.
There's enough there to write a primitive web server. You can parse CSV files, parse XML, parse JSON, generate XML, generate
Get
JSON.
information about your operating system, and make.
So at that level, if that's all you needed to do, you're set, just downloading the Python that's on python.org. But if you need more goodies, then you can fall into this dependency trap. In the Unix world, they used to call it dependency hell, where your problem is solved not by something that's built in, but you need library X. Well, it turns out that library X depends on library Y and Z. and
Mhm.
Y depends on A, B, and C. And you can start following this, like, oh, I need to get that, and that. And if you just try to do it manually, you're in a world of hurt.
Mhm.
So the next step is, depending on what you're trying to do, you could go for a richer distribution. You know, that's what Paige was mentioning about,
Mhm.
like Canopy and Anaconda. Those are Python distributions that take everything that was in the core and give you a bunch of extras. Now, those extras were primarily aimed at science.
Yeah, so this is, on the screen right now is an example of what Thought Canopy looks like. But yeah, and the people who I know who use it are primarily using it as an alternative to MATLAB and Mathematica, which are, again, like if you're operating on a student license, it's like $100, you know, kind of easy to wrangle. But if you're operating as a corporation or something that's making money, you're going to be paying out the nose for MATLAB and Mathematica. So, and Thought Canopy, Anaconda.
What does Canopy cost?
Nothing.
Nothing.
Okay, so there's a community edition that has the things that most people care about, and that one is free. There is the full, like, probe version that has a cost which is reasonable.
Mhm.
And I don't know, it's on the website.
$995 per year, which,
No, not as reasonable.
or maybe $995 altogether. Let's take a look.
Okay. However, if you have an edu address, there's an academic license, and so you
Mhm.
can get the pro version for free.
Yep.
That's
Now-
only for college level.
Yeah. Now,
High
either
school,
way,
they don't get EDU.
at some point, you're going to want to install a library with dependencies anyway. I mean, this will defer, it'll delay you
The
needing to
triple thing.
install your own library. And
I was looking
it
at
will solve
enterprises.
the problem of installing some of the hardest libraries. So if you're doing sciencey stuff, there are libraries, foundational libraries, that are really hard to install manually.
Mhm.
Specifically, there's a library called SciPy, which
Mhm.
is not pure Python code. There is Fortran code
Mhm.
buried in there. And getting that installed, and getting like Fortran compiler versions to match up,
Mhm.
and, you know, it's actually kicked my ass twice.
Why is it so hard?
Because back in the day, when they were tackling crunchy numerical programming, like how to form the inverse of a matrix, and they fine-tuned it to be efficient and also survive matrices that were poorly conditioned, and yet still be efficient if the matrix was well conditioned. They
And
solved all
also
that
small
in Fortran.
enough.
And that was a long, slog, hard battle, but it all got solved. Nobody has the heart to rewrite all that code in C.
Yeah.
So if you're doing hardcore, crunchy numeric processing, somewhere deep down there is Fortran.
But it must be worth it. It must be fast.
And,
Yes.
and then,
I'm gonna try to use it, right?
Yeah,
Well-
so a good solution, if you're doing sciencey stuff, is you started with a distribution, even the free one. And like Anaconda is also just free.
yeah, and they have
That
people
will
outside.
get you over that Fortran hump. And now only worry about installing the libraries that are easy to install, but then you've got to solve that dependency problem. That's where something like virtual env comes in, and pip, is the
Yeah.
ability to install a package and all of the packages that it depends upon
Yeah.
in some little local sandbox. I'm going to create a sandbox, I'm going to install this stuff in here, test it out, see if it's working. If I don't like it, I can always just blow that sandbox away and leave the rest of my Python working.
When you,
Not VirtualBox, so this is virtualization at a lower level.
Yeah.
Where all you're virtualizing is not the operating system, but just the Python
Python.
environment.
And also for,
Similar to what Docker's trying to do.
It's even lighter weight than Docker.
and Anaconda, also, I'm not sure if Thought allows you to do this, but Anaconda allows you to bounce between versions of Python.
Yes,
So-
you can, Anaconda, it's got a different package management system, but it's all about creating these lightweight, they're kind of like Docker containers, but lighter weight
Yeah.
environments that can include some nasty dependencies. They're cheap, so you'll always have like a master one, and then you create a bunch of ones that depend on that master, and these ones are lightweight. And then you can install, since they're cheap, you can throw them away. you install a library with dependencies into one of those environments. So you create the environment, you install your stuff, you're working on a different application, you create another environment, you install different stuff in here. And if you're using pip to do your install, so you go pip install package X, as long as package X was up there on the Python package index, then pip would go out on the network, grab that package, take a look at it, and say, oh, it's got all these dependencies. And go and grab all those dependencies and shove it all into this environment directory that you just created.
Yeah. So, and this is the open source version of ArcGIS that was talking about with the Texas parks loaded. Quantum GIS. And it has Python embedded as a terminal, but then also you can make potential Python plugins for it. I'll be talking a little bit about that tomorrow. But yeah, so basically this was intended to be, if you have any questions, like feel free, yeah.
If you're working with a team or even just one other person, if you're using GitHub and you like picked, you know, the number of libraries or whatever that you're using, and you upload your stuff to GitHub, how do you make it clear like how someone else can match an environment?
What you do is pip freeze will admit to standard output all of the libraries and their exact versions that you have.
Yep.
So first, you have your developers create like the minimal environment that actually ran, because you don't want to have like false dependencies that aren't necessary. Once you've worked that out, so you've got this file that is listing what the versions were and what the dependencies and the versions were in this standard format, you call that file requirements.txt and you put it at the top level.
That's what that means.
Yeah, yeah. So this is an example of what pip freeze would do. It spits out all of the libraries that I have currently installed. So that
What's on your ACES? What is that again on your ACES thing?
Ubuntu 14.04,
No, the program you're talking about for GIS.
Quantum GIS. And I'm currently using 2.0.1, which is called Do4, but I think there's a new version. But yeah, so it's, and version control is always difficult for everyone. Yeah. So if you want to know of good books to start with to learn Python, if you want to know of great websites, or I know Code Academy is kind of the newest and latest and greatest flavor of online learning for this, but really, like, there are tons of resources available. It's just a matter of finding one that fits you and fits your needs and fits the time that you're capable of allowing to learn. So if you have any more questions, if you would like to get Python installed on your machine, or Anaconda, or Nthought Canopy,
We've got time. If you need installs, we can help you.
absolutely. And it is kind of tricky at times to get things installed on personal machines.
How long does it take? Would there be any benefit to getting all three of them, or you just choose one and go?
Okay, so I have all of them.
Samesies.
And they don't fight. You can have, I don't know how many Pythons I've got on my laptop. And all I really need to know is which one I'm running for the application I'm running at that moment. So they all install into different directories. They're not going to conflict. They're all easy to uninstall. Usually there's just like some top level directory that you blow away and poof, it's gone. As far as which to select, if you're wanting sort of the more hand-holding, Canopy is better because it's actually got this bundled sort of like launcher environment that's going to give you.
Yeah. If you'd like to play with it, I'm pulling it up right now.
A documentation viewer and an editor all bundled together. If your Anaconda is more, if you're more of a terminal jockey, you'll like Anaconda better.
Yeah.
If you don't like the terminal, you'll like Canopy better.
Yeah, and I actually am a fan of Anaconda with what little I've played with it.
Anaconda has a theoretically more robust package management system. So if you're managing environments and dependencies of the command line, Anaconda is more robust. But it's weird because they've got their own separate command. Instead of running virtual env, you run conda, create.
Yeah.
But either way, then once you've created these little lightweight environments, they're kind of like containers. You then just install the stuff you need in there, and using pip, and then you can do things like pip freeze and to get that requirements.txt, and then anybody else who wants to use it would just download the software, run. There's some pip command where you pass the requirements.txt file, and then it creates a corresponding environment.
Yeah, who was talking about that just recently? Paul Bailey was he gave a meetup presentation recently all about pip freeze and about how to manage packages within that. I think the presentation might even be online, and he's definitely here if you want to talk to him about package management later on.
Yeah, one thing about the Python distro itself, the core one, is just like 20 megabytes or something. But the beefy distros like Canopy, you're like 300 megabytes. So over Wi-Fi, the download is slow.
Yeah.
You watch out for that.
Yeah.
You know, I'm sorry to keep talking, just have another question.
No, we love it.
You know, one of the things that when I think around with Python, and I wish I could ask some dumb questions. Ones that I would be too embarrassed.
Ask a dumb question.
I would be
Agreed.
too embarrassed to put on, you know, any place on the web for I would, you know, criticize.
You don't put anything serious on Reddit, like, unless you.
Well, but I mean, if I went to that one, that Stack Exchange, and I mean, I don't know. I mean, I haven't seen anybody really, you know.
Well, the thing is, if
Yeah, but I mean, they're just questions that I have, like you know, there's something like if I'm reading, when I was trying to figure out how to read large files, I read all this stuff and I looked at it and I couldn't. I was trying to read this appraisal file and I just couldn't get it right because I wasn't sure which one I was using and when I was using it, I wasn't getting the answers I wanted. But it would just be nice to have, you know. So I thought about what if there was some sort of network of I don't know. I wish it was a network of instructors or people who would be able to teach
Right.
this.
So
that
there are mailing lists.
Well,
Yeah.
okay.
So like there is a Python Texas mailing list.
And there's also Python tutor offered
Yeah,
through the
which is not
PSN.
Texas specific, that's global.
Yeah.
If there's a meetup group in your town, there's usually a mailing list associated with that. So there are these opportunities you have to decide, you know, am I going to ask my question to the world, like Python tutor?
Yeah.
Or am I going to like make it smaller scale? Do I want a permanent record? It's now in the archives of that mailing list. Or do I really want this to scroll off the record? In which case, go use IRC. There's an IRC channel for Python that you can jump on and ask questions. And it's always live. There's always someone on that channel.
There's a PyTexas IRC channel too, though I'm almost always the only one in there.
So you can ask Kevin here.
Yeah. And there's also, so the Coursera course that I had mentioned initially, the one that's sponsored by Rice, though there are Python courses on Coursera and edX sponsored by so many schools. They come prepackaged with forums. So like if students have questions, they have self-assigned TAs and they also have TAs from the school themselves who just like go through and try to help if you have questions about the assignments, questions about Python in general. Like usually there's always somebody who's pretty responsive. And these MOOCs, the people who get into them get massively into them and just kind of like go through to try to show their expertise.
Beyond GitHub, do you have any other ways to recommend finding other people in the Python community that are into the esoteric things that you are, like your data?
I mean, Google it. Google it. Look on Twitter. Start a meetup group in your town. Where did you say you were from?
I'm in Austin.
Austin, oh, heck yeah.
You
There
see
are,
all the time. I mean, I know
dude,
this.
there are tons of people in Austin who are chill. Like,
I know, there's
There's a
it
meetup.
just, yeah,
There's a
meetup.
meetup. There's like 10 meetups for Python in Austin,
Yeah.
at the very least.
Yeah, and just if you don't see a meetup group that fits your interests, just say like government data analysis with Python or something. Start your own meetup group, and like I guarantee you, in Austin, you're gonna get folks. You're gonna get so many folks.
Especially with the startup scene,
Yeah,
dealing with oil and gas.
Yeah.
It's insane
yeah,
how much of a response you would get.
And be aware, you're probably going to underestimate how applicable your question is. I mean, about the Stack Exchange or Stack Overflow. Yes, you could. There are some questions that truly are just unique to you. Like, why is there a blue car in front of my house? Well, that's just for you. But almost every programming question can be generalized to, to take out the stuff that is just specific to you, and you say, these are the lines that broke. This is,
Yeah.
this is, if you put any effort at all into generalizing it, and you ask that question, and then an answer appears, you have created value to the body of work of our civilization. Because you're going to underestimate the number of people that are going to encounter the same thing.
and usually, I mean, the Python community is pretty friendly. It seems like everybody's willing to help if you have a question.
Yeah, it's a no-flame zone, so
Yeah.
just,
Yeah.
I'm not sure I want to test that. No, really, I mean, it's,
Yeah. So again, if you,
data ranking, system administration, working with Excel, making games.
yeah,
Oh, what about databases? Yeah, there's
Yeah.
like MySQL or
Every
SQLite,
database has Python bindings.
yeah, and the core comes with SQLite 3, I think.
Yeah, so Python bundles, so out of the box, bare bones Python, you get SQLite 3. If you get one of the distros, you'll probably get bindings for other databases, but every database has Python bindings, including really exotic ones. Well, maybe not the most exotic ones, but all, like not just the SQL, so like MySQL, PostgreSQL, Oracle, all of those, of course. And obviously, that's a lot of the NoSQL ones. So MySQL, Redis, Couch, Cassandra, Neo4j. Now that's one written in Java. There are Python bindings for it to get a graph database.
When you say bindings, do you mean that you can use Python scripting instead of the SQL language to query your data?
Okay, if you're dealing with an SQL database, usually there will be SQL in your code somewhere, often parameterized SQL. And what Python is responsible for is usually firing off that query with the data that you want to parameterize that query to, and then doing something with the results beyond what SQL can do. Maybe it's turn it into a table, put it up on a web page. There are some libraries that will let you generate SQL from higher level stuff. Like one of the classic ones is ORM, O-R-M, Object Relational Mapper. And this is like in Django. If you're doing a Django website, you're going to define classes that are going to map to tables in an SQL database. And there's an Object Relational Mapper so that most of the time, it's often cases for some applications, all of the time, you're never writing SQL. In other situations, if you're not thinking about mapping objects to a relational database, but instead you're just thinking of a relational database as a data store that you're now trying to just pull data out of, there are a few libraries here and there that will provide like a Python syntax. And it's going to have to generate SQL under the hood anyway, because that's what the database speaks. But I'm not sure how much they're used because SQL is a language for fetching data out of SQL databases. So you wind up in a sandbox where at some point there'll be some query that library can't do, but SQL can do.
Yes.
And that you can run your script code. What's the benefit of installing full-fledged one of these?
Okay, so Code Sculptor, it really is just a sandbox that you can use to play with Python syntax. You can create things like the games that I showed you, right? Like those are all running internally, with Code Sculptor. You can create a pop-up that has a heart that says "I love you" and sends it to whoever you happen to love. Like those are nifty small-scale projects. But if you really would like to get more involved with Python, I would suggest downloading Python itself, at least, or Canopy, or Anaconda.
Do you guys know off the top of your head which one is like least taxing
At least, taxing?
Yeah, the least, which one's the smallest?
Well, so the
Python.
bare bones Python is just going to be like 30 megabytes.
Yeah,
Uh,
you can download Python quite quickly, or it might already be on your operating system if you're running Linux or
Any Unix, pretty
yeah.
much.
Yeah,
So that includes Mac OS will ship with a version of Python. It's really only Windows that you are Python free.
yeah. So if you open up a terminal window on your Mac and you type Python, you should.
Huh?
So just type Python.
Yeah.
It'll tell you which one you have installed.
Yeah.
That's the first thing it prints out is Python version such and such,
Uh-huh.
and then it gives you those like 3 greater than symbols to indicate, start typing stuff.
Yeah.
Yeah.
And if you're on Windows?
If you're on Windows, then you absolutely have to download something.
Yeah. And you can just go to the Python website. Let me pull it up.
You got better operating system.
So as far as taxing, if you're not running Python code, it's not taxing your operating system at all, except that it's occupying space on your hard drive. So like the bigger distros, such as Canopy and Anaconda, it's like, well, as long as you've got half a gig of space that you're willing to spend, then you spend it. And then if you're not doing Python, it's not costing you anything. If you're just doing bare bones Python, and you've got the heavier distribution, it's not like it's going to consume more CPU resources while it's running. It's going to just take the same amount of time, whether you're using the bare bones Python or a rich distro, because it's under the hood, it's actually the same engine written in C that's running. It's just that the beefy one that was filling up your hard drive had all of these libraries already installed, so you didn't have to install them. That's really all you're getting with the beefy distro.
So that's the website if you want to install bare bones Python. And then you have the choice, the magic choice of whether to download 3.4 or 2.7.8. And my mouse pointer has no bearing on the recommendation.
Okay.
So,
The reason not to use 3.
yeah.
It used to be that 3 was being held up because there weren't the libraries, and people used.
But now it's basically all
That's
green.
solved the problem.
Yeah.
Now the real concern, the thing that's holding up 3, is that the books mostly haven't caught up. Like Python the hard way,
Yeah.
still 2.7.
Yeah.
And which is ironic because one of the features between those two languages, just as like looking at them as programming languages, if there were no books written at all, Python 3 is easier for newbies than Python 2.
Yeah. And if you ask, what?
So Python 2 made decisions back in the 80s that were wrong. They seemed reasonable at the time, and that meant that today those decisions show up as friction when you're learning. So the way the print statement works, that it's a keyword rather than a function, and the syntax, especially if you want the output of the print to go to something other than just standard output. You want it to go somewhere else. You've got some ugly syntax to do with that.
Yeah.
How international text works. Python 2 conflates the concept of binary data and the concept of text. And they added Unicode. They did it in a good way, but it is still rising up from the original C language roots that Python was written in, and thinking at it from that perspective. So if you read a binary file in Python 2, as you're reading chunks of that, what you're getting are strings that happen to contain crazy binary data rather than stuff you could print out.
So you're saying there's no real compelling reason to go to 2.7?
The
Yeah.
reason to use Python 2 is because you have a book that's in Python 2, or you have some other business requirement like your job
Yeah.
that's forcing you to use Python 2.
Yeah, and also when you tell Zed Shaw, like, because Walker and I had this discussion a little bit recently about porting all of the code samples from the books into Python 3 code instead of 2.7. So I tweeted at Zed Shaw, and I was just like, yeah, and I was just like, hey man, so I really like your book. It's baller. I'm thinking about using it for a course, but I kind of want my people to be using a later version of Python. So is it cool if I go through your code samples and I just like modify them? And he was just like, no, I'm fine with you using my book, but like, no, why are you using 3? And he went through and tried to give justification for staying on 2.7, but it's all like, as far as I'm concerned, if you're gonna start learning and you're learning now, download 3. Like there's no reason not to. And it's,
Think like a computer scientist have Python 3 yet?
I don't think so, no. But that is an excellent book. How to Think Like a Computer Scientist is an excellent book.
So this is where Java got it right, and then Python eventually caught up. Binary data and text. In the Java world and in the Python 3 world, those are two different concepts. That way, you're not tied to ASCII, the American, whatever name was, that could only deal with the Roman characters used in English. Couldn't even deal with people with Spanish names that have like, a tilde in there or an accent. None of that worked, at least in ASCII. And so then you have things like Latin 1 that could at least work with Spanish and French, but nothing else. Couldn't even work with German. And the right way is to say that there's text. Text is Unicode. You don't think about what it is under the hood as bits of ones and zeros. Just think of it as text. The German S set, it's the S set, that's all it is. And then there's binary data, and that's for like your media, MP3s and such, or other like encoded data. And if you need to move back and forth between them, then you have to know what the encoding is. Is it UTF-8? And so your program, when it's dealing with text generated by human beings, it should process that as text all the way through. And at the edges of your program, when it needs to write it to a file or put it on a wire as a message, as a series of ones and zeros, then it's got to encode that to a particular binary encoding to send it out. If it's receiving a message, it's got to decode that message as a particular binary coding to convert the bytes into the text. That is the right way to do things. And that's what Python 3 does.
So basically, library, philosophy of library system.
Right, and then the natural, obvious way to handle text will work with people in China. If you do the natural and obvious way in Python 2 with handling text, you're going to make mistakes, and it's going to mess up when you're dealing with people in China. And so that's the friction. You can do it. There's nothing that you can do in Python 3 that you can't do in Python 2, but as a newbie, you'll make mistakes.
Okay, so like, you're changing the curious, there's no reason to stick with Python 2.
Yeah.
Right, I mean, that's a good example. In Django, Python 2 is a friction point because the web is all about Unicode.
Yeah.
Somebody opens up a form and they type their name and it's looks like hopscotch. And if you're doing it all as Unicode from end to end, it's seamless. It comes into the database, it comes back out. The guy never sees his name mangled. There's no angry emails.
And it's also constantly evolving, right? Like why stick with something that's just going to be changing to the latest and greatest version? Like you mentioned ArcGIS, which was one of the reasons why I was still bouncing around with 2.7, is moving to 3. So move to 3, stay up with the times. This is also, so No Starch Press is an excellent publisher of programming books for a variety of languages. Python for Kids is also excellent if you have a small child in your life, or if you consider yourself to be a small child at heart. And then also other books would be Pact Press. They are phenomenal, and O'Reilly manuals. So,
What was the one before that, the website?
no starch. Yeah. And then the next one is Packed with a T Publishing. These also come with code samples sometimes. And the nice thing is too, if you're a person or a student with limited income who acquires ebooks through alternative means, if you email the nice support people from Pact Publishing, they will send you a copy of the data that comes with the ebook or the real book. So if you just look right, if you look in the, where's their search bar? There we go. So if you search for Python on this site, it comes up with a variety of things that you could use. So data visualization cookbook, machine learning, geospatial analysis. There's an ArcGIS 10 cookbook with Python published by these guys, and it's phenomenal. It also comes with code samples. But yeah, everything. And O'Reilly, basically any book that you could get from O'Reilly is going to be a solid bet. So 354 results. Python cookbook is probably the best one.
The third edition of the Python cookbook is targeting Python 3.
Okay. More evidence.
The second edition is still worth reading now.
Word.
I have both of them, and I still read them both all the time.
Mm-hmm.
And version 2 and version 3, they're not that different. In fact, there's a common subset language between the two. You can actually write programs that are both legal 2 and legal 3.
What about GUIs? There's, you hear about PyQt and TK-Inter or TKinter or whatever it's called.
Oh, yeah.
First, ask yourself, do you really need a desktop GUI? Or could you do with the web GUI?
Somebody's going to run the code and I'm gone. I don't know, just thought about it. Something like that. I could just rig it as shoes.
Okay, if you're going to do a GUI, I'd avoid TKinter. If you're
Yeah.
going to do a desktop GUI,
Mm-hmm.
it's going to be Qt.
Yeah. Or import simple GUI if you just needed to do a few things.
Does simple GUI run outside of Code Sculptor?
Oh, I think so, yeah. I'm pretty sure. Like, it should be, let's look at the Python package index if you,
Another thing to be aware of, if it's just that you didn't want people to have to go to the terminal to run the thing, like say it's going to just take file A and massage it into file
yeah,
B.
it's,
On Windows, you could write a bat file and have it like pass the parameter to the Python script, and that's a drag and drop operation. So if you create a bat file and you do it right, you can drop a file or a directory on top of it, and have the bat file pass that to the Python script and go chunk up. And I've done that in my previous job. That worked well. The one thing though is that either drag like a collection of files that are all the same, or drag a directory that contains files. But if you drag a collection of files, like where one's a data file and the other's a parameter file, well, you don't know what order they'll be passed into Python. And so that's the tricky bit. Then your Python code would have to like look at the names of the files to go, oh, this is the parameter file and the rest are my data files. That's a way to get around writing GUI, and what the user experience would be is that they pick their thing in Windows, they drag it on top of the bat file, when an ugly terminal appears, chunka, and then it goes away, and the output is just sitting there on their desktop or wherever window they were in.
yeah. And import simple GUI is something that you can download from. Yeah,
Oh,
yeah.
so it wrapped to Kinter, and that's,
Mhm.
okay.
Yeah. But anyhow, if there are any other questions,
I came in kind of late, so this is my big question I already asked, but what's the coolest project that you worked on with Python?
The coolest project that I've worked on with Python. It was probably building a game in college, actually. I did a bouncing frog game. I'm not cool enough to be in the Hall of Fame, or, well, they didn't, my class, the one that I was doing my sophomore year, they didn't have this website up and running, so they couldn't put things in. But it was a bouncing frog game.
I've got one that's cool.
What?
So, at 2 jobs ago, I was working with a game company that did cell phone games. Now, this is before iOS and before smartphones, so this is still on feature phones. And we were contracted to do the game for the Batman Begins movie.
Whoa.
Yeah, so I actually got to read the script before the movie. I knew how awesome it was going to be.
Uh-huh.
And the thing was, we had to generate 2 different versions of the game. One would be in Java for one kind of feature phone, and the other was going to be in C++ for all the Verizon phones. And so this was like really tedious because they're very different game engines, very different GUI systems, but there's large swaths of the game that's going to be the same code in the 2 worlds, except this one's C++ and that one's Java. But the variables can all be the same. There's just slight differences in the syntax. And so what I did is I wrote an engine where if I had the right special magic comment blocks in the Java code, it would clip out these sections of Java code into separate files, then translate the Java to C++. And then in the C source code, I'd include statements to slurp in those passages.
Cool. So speaking of Python games, because I can't talk about Python games without mentioning this. There's a lady named Christine Love who created this BBS, if you're familiar with it, a themed game using something called RenPy, which you can also use. It's a gaming engine for Python that allows you to create sort of more text-heavy computer games, bless you. And most of them are manga themed. So this, you download it to your machine if you'd like to, and it comes with all the Python files so you can investigate how it's created. Lots and lots of fun. And the engine that it's using, again, she wrote it. She's very, very approachable via the Twitter, but it's RenPy, the Python visual engine. And you can make games like this. Again, very text heavy, but lots of fun. So. And again, if you're a student and you don't want to be paying for MATLAB and your professor doesn't really have a requirement about how you make your plot to show whatever equation, like think about downloading Anaconda or Canopy. It's a good alternative.
Yeah, when you do that download, if you're trying to, what they'll have is something called pandas, and which will give you like an R-like environment for processing data. Matplotlib gives you the environment for generating the plots.
Yeah. And if you have any questions at all, I probably should have put this on the slide. But this is that is my email address. Feel free to contact me anytime with any questions. And if I can't answer them, I will be happy to point you in the direction of someone who can. Excellent. So I'm letting you out.
It's about JSON parsing for XML.
I guess that's for the 101++ people.
Yes, sir.
Yeah. But yeah, letting you out 15 minutes early. I'm sorry I kept you here for so long.